Hey guys, this video is going to be on how to connect and program a Microprostar radio, and again using the same FTDI serial converter cable plugged into the Microprostar. And unlike the MP8K, the Microprostar has to be set to calibrate mode, and the LCD should say press option, so it should be set up just like that. Now again, unlike the MP8K PC applications, this MicroStar 2000 application, you don't have to add the COM port number to the command line. There's actually a place in the options once you run the program where you can specify the COM port. So let's go ahead and run the MicroStar 2000 PC interface, and this is what comes up. As you can see, there's a lot going on here. You can pretty much do all the programming here using the PC application that you can in the radio itself. Of course, this is probably a lot easier than using the radio, using the stick to go through all the menus and change all your options in conjunction with the option button there. It's much easier here in this, graphical user interface. So let's just kind of walk through some of this. So the first thing you're going to want to do is come up here to File and go to Options, and we're going to want to make sure that the COM port number here corresponds with the COM port that's assigned to our cable and device manager, which I just checked mine, as you saw in the previous videos. Mine assigned COM port 13. So you're going to want to make sure that matches what your computer shows. And then once you do that, you can come here to Link and you can click Read All. And what that's going to do is that's going to read all 96 model memories that are present in the radio. And that way we can, here on the PC software, we can step through each model, we can make changes to them, and then we can write that information back to the radio. So let's see here, let's go ahead and read all, and it's going to give you this little connection message here to ensure that your MicroStar 2000, or in this case we're using a Microprostar, which is an ACE Micropro 8000 that's been converted to a Microprostar using Dan Thompson's Microprostar adapter module. So with either radio, this is just telling you that it needs to be in calibrate mode, and it needs to say on the LCD press option for the radio to be able to communicate with the PC application. So ours is set correctly, so let's go ahead and click continue. And as you can see, it's going to give us a progress bar here while it reads all the model memories that are in the radio, which I've only really done something with 2 model memories. The model memory number 1, I have a FunJet that I've started programming, and I've also played around with model memory number 96. I haven't actually given it a model name yet, but I was just using it for testing of the helicopter mode. So there's really not a lot of information stored in the radio as far as the model memories go. So I don't know if it always takes this long, or if possibly it takes longer if you actually have data programmed into more model memories than what I've used so far. I don't know. That could be the case, could not be the case. I really don't know at this point. That'll be something I can experiment with. But I mean, it hasn't really taken that long. Looks like it's almost done there. There we go, all aircraft data read. And so it shows my model memory number 1 is my FunJet. And as you can see, there's a lot here just on this main aircraft screen. You can set whether or not you have a alternate aircraft established that you want to switch between and what switch you want to use. You can set a retract warning if you're running retractable landing gear. Clear your trim zeros. You can set what mode of auto trim you want to use. I have mine set to off because I want to use the default like MP8K auto trim versus the incremental, or I think it's called one-shot method. And this is where you can enable and set your deflections for left and right snap roll. If you have a snap roll switch on your radio. And this is the flight timer. This is what's great about the Microstar 2000 and Microprostar conversions is your flight timer or model timer, however you want to say it, is specific to each model memory, where the Micro Pro 8000, the ACE MP8K, the flight timer is global, so it's not model specific. So each time you switch a model, you have to go in there and change how long you want your flight timer to be, and then you can only start and stop and reset it using the option button. Whereas here, I have my FunJet programmed, you know, it's a 120 mile an hour airplane, and I like to go, you know, do some fast passes and then get it up high and go power off and just glide around for a while. So I like to have the flight timer slave to the throttle stick, and you can actually do that with the Microstar 2000 software and program that to a Microprostar even. So in my case, I have my countdown timer for 8 minutes slave to the throttle pot, and I have the target amount is 10%. So any throttle setting over 10%, the countdown timer is going to run. Anything below 10%, it's not running. So when I'm, you know, power off or very low power glide, my countdown timer is not running. So that's a really neat feature, and that is model specific. It's not a global setting, so that's very cool. So again, I'm not going to really go in depth on all this. Servos, this is where you can do all your servo calibration, you know, your neutrals, your endpoints, your expo, your dual rates, etc., etc. Let's see what else is in here. Sub trims. You can set your channel 5, 6, 7, and 8 on there. Here's where you have your mixes. Here's my, of course, my FunJet's an Elevon airplane, so I have the Elevon fixed mix or predefined mix enabled. So you can do all your, you know, your mixes just like you can your Micropro 8000. Shared options is where you can set, there's I think 2 aircraft and 8 global tables. These are like setting curves. You have 11 points here. So in the helicopter mode, where you can assign a table for both the collective pitch and throttle. So you can have a throttle curve and a pitch curve for each flight condition under the helicopter mode. This is where you set that. It's 11 points. That's as good or better than even some of the modern radios, which is great. You know, you can run an exponential curve, a linear curve. If you have a throttle curve, you can, in a stunt mode, you can run a V curve, where if you have your collective pitch set at center stick is 0 degrees collective pitch, you know, you can have your throttle curve where high stick is 100% throttle, you know, mid stick might be 80%, and then low stick might be back to 100 because you're pulling negative collective pitch. And then vice versa, you could set this curve up for your pitch curve. In like a normal mode, you'd want the middle to be 50%. If at half stick, your head is set up to have 0 degrees collective pitch. So from half stick to full stick, it goes from 0 to, let's say, maybe plus 10 or 10 positive degrees of collective, or more, or maybe slightly less. Halfway is 0, and then down at low stick is, you know, again 100% negative pitch, so it may be 8 or 10 degrees negative pitch. So you can, you know, you can set independent throttle and pitch curves for each of 4 different helicopter flight modes, as I'll show you in just a second. Let's see, this is where you can set how many channels you have. You can do some calibrations on the transmitter and receiver voltmeters, and you can specify the channel order output for your receivers. Like you can, you know, use ACE as standard, where you got elevator, aileron, rudder, throttle, or Futaba, Airtronics, or JR probably, you know, has those. You click on those and it changes what these defaults are as far as outputs go. This is a diagnostic mode, you know, to read data for your buttons and switch data and positions for your pots. Same thing for this. This has to do with the analog to digital converter. I think this has something to do with the MicroStar encoder, so I don't mess with that. And then here's the helicopter. This is very neat. You got you can enable the helicopter mode for this model memory, which I'm not. This is an airplane. But if it was, you could enable the helicopter mode, and then you could, if you're not running a mechanical mix, if you're running a 3-servo collective cyclic pitch mix, CCPM, you can turn that on, and it's got 120 degrees, which is what most models use. And then for the few that have 140 degrees, you got that. And then maybe some of the older CCPM helicopters that utilize a 90-degree servo orientation for the CCPM, you have that option also. And you can reverse pitch here if your pitch servo is backwards, which is nice. And then you have 4 different flight modes under the heli. You got normal, throttle hold, which is what you'd use, you know, for an emergency landing or, you know, shooting auto rotation landings. And then you have stunt 1 and stunt 2. These would be where you'd have set your collective stick and throttle stick, where your pitch curve would have, you know, center stick would be 0 degrees, and then high stick would be positive, let's say 10, maybe even 12 degrees. And then low stick would be negative 10 or 12 degrees type of a thing. And you can run an independent throttle curve to where you've got high throttle at those, you know, the parts of the curve where you have the most pitch. And then the area where you have the least pitch, you could bring your throttle value down some. Again, you got 2 different stunt modes where you could do that. And then you have a normal mode here, where you know, your throttle curve may be more linear, and your pitch curve may, you know, not go to the extreme on the negative side. It might only give you a couple of degrees of negative pitch. And then you can run different gyro sensitivities for each one of these, which is handy because, you know, in the stunt mode down here, you might be running a higher throttle curve where you get a higher head speed and it requires less gyro gain, versus a normal mode where you might be running slower head speed where you'd need more gyro gain. So that's pretty handy. And So again, you can make changes to each aircraft, save each aircraft model memory independently, or you can save all of the ones that you loaded from the radio. And then as you make changes to it, you can go here to link. Let's say I made a change to this FunJet parameter or model memory, then I can write whatever changes I made right to current aircraft, and it's gonna send that information back to the model memory on the radio to update it. So you can read info from the radio to here, make backup copies to the computer, make changes to it, and then write it back to the computer. You can create new model memories from scratch, make whatever changes you want, write them to the radio, and then once you get synced up with your model as far as bound to a receiver, you can make additional changes here in your radio. And then next time you communicate back to the computer, you can save those model memories back to a PC file just to have a backup in case you make a change on the radio with the firmware or something, or something happens where things get set back to defaults, then you have a backup copy there. So again, this video was just to illustrate how to hook up a Microprostar to a Windows 7 computer, as far as how to connect it, what mode it's supposed to be in, calibrate mode, etc., how to set the COM port and the options on the MicroStar 2000 software, and then just a brief overview of what you can do with this program. Again, it just scratches the surface. So I hope you guys find some value in this video. Thanks.